Hello everyone and welcome back to my YouTube channel. In this video, we will start working together on a new SwiftUI project, a very simple weather app which could easily be chosen as a take-home project for a junior iOS developer job interview. There are a lot of companies out there that are hiring based on skill rather than education. Giving you a take-home project is not unheard of. In fact, it is becoming a normal occurrence. And it is usually something that a job candidate should be able to put together in about 5 to 7 hours at home without much difficulty. We are going to build this app composed from just a few different screens, using the SwiftUI 2.0 interface and the new SwiftUI app lifecycle. Now this app is not going to look very fancy on the screen. Basically, we're going to have a black and white user interface. No colors, no gradient backgrounds, no custom fonts, no fancy shadows. We will not focus much on user interface design in this project, since that is usually the job of a designer. But don't be fooled. Implementing this app is going to challenge your knowledge about programming in Swift and SwiftUI, proving to a potential employer that you are skilled in understanding key Swift programming concepts necessary for any junior developer. In part 1 alone, we will already prove to an employer that we understand concepts like static versus instance properties, loading resources from the app bundle, structures versus classes, extensions, and the JSON format is now the standard in data transmission over the internet. We will learn to decode JSON data after we understand what the codable protocol means, and we will learn to do all of this in a new, more powerful way by making use of the new result data type. I love this result type, and the powerful flat map function. Stay with me to the end of the entire series and we will learn together a lot of other key concepts for programming in Swift and SwiftUI. Alright, enough said, let's get started. The first thing we need to tackle is figure out where should we get the data from. After all, our app will rely on data provided by some weather service out there over the internet. I'm pretty sure there are a ton of online services that provide weather-related data in one form or another. But the service I decided to use for this project is called Open Weather Map. They are a team of IT experts and data scientists based in London. If we choose some other service, while the exact details of the data they provide might be a bit different, overall the way we write our code to use the service will be the same. So let's take a look at their website, openweathermap.org, click on API, and let's see what they have to offer. At the time of this recording, OpenWeatherMap is offering 9 different types of APIs under the current and forecast weather data collection. However, we are interested only in those that are free for us, for now. Out of the 9 APIs available, 3 of them are offered for both free and paid subscriptions. Current weather data, One Call API, and 5-day, 3-hour forecast. If you want to take this project to another level at a later time, maybe building a real app for the App Store, I strongly recommend looking also into the paid subscriptions. Now, out of the 3 free options, the one that got my attention is the one entitled One Call API. It offers current, forecast, and historical weather data, minute forecast for 1 hour, hourly forecast for 48 hours, daily forecast for 7 days, historical data for the previous 5 days, and national weather alerts. There's a lot of data here to work with. We will only use part of all of this. What we want to know from the start is the format in which the data will be provided to us, and in this case, we see the format provided will be JSON. JSON stands for JavaScript Object Notation, and it is a lightweight data interchange format. It is definitely not the only format used for sending data over the network, but it is the most used one these days. Any developer working in any programming language must know how to work with this format. I did use this word, API, many times already, but before going any further, we need to take some time and understand how to work with any API in general. The acronym API stands for Application Programming Interface. This interface defines the interactions between multiple software applications. It also defines the types of requests that can be made and how to make them. Now, why are we talking about multiple software applications? Well, that's because in order for an app like ours to work, we need to deal with at least two different software applications. One is the caller, also known as the client, and a totally different software application is the server, also called the provider. Between these two applications, there is communication taking place. The client makes an API request and sends that request to the server, usually through the internet, but not always. The server, in turn, formulates an API response, which is then sent back to the client. Now, the client, having a response which usually contains data, can interpret this data and display it in a user-friendly manner on the screen for the user. We are basically dealing with APIs every single day, even if we don't realize it. When we open a browser and type the address of some website, the browser is sending an API request over the internet to another computer somewhere. This computer, which is running a server application, compiles the request and sends back an API response containing the data that was requested. The browser which initiated the request is not done yet, however. That's because the data received from the server is usually in a format called HTML, which is not what the user wants to see on the screen. So now, the browser interprets the data received and builds a series of layouts, images, links, text, and colors, which is what the user gets to see on the screen after all. This communication pattern is very similar to what apps are using, and our app will not be any different. Just like the browser, an app sends an API request to the server, usually over the internet, and this server will have the role of serving data to our app. It compiles data into a specific format and sends an API response back to the client. There are many different formats available out there for different APIs, and some of them are JSON, XML, HTML, plist, and many more. In order for a developer to know what format to expect the response data to be in, they will need to read the API documentation. And we have done this already. We know that the data provided by OpenWeatherMap API will come in the JSON format. The key point here is that the app is not done yet. It will have to take this data received from the server and build a user interface with that data and present it on a screen for the user. That is going to be our main task as developers. That's pretty much what we do as front-end developers. And part of that job is to read and understand very well the documentation for the API we are going to work with. So let's go back to our OpenWeatherMap website and click on the API doc link for the API we have chosen, entitled OneCall API. This page will give us information about how to make an API call and about the parameters that are required for this API to work, if we scroll down the page a little. So what do we see about making an API call to our weather service? Any API call starts with a base URL. In our case, this base URL is https://api.openweathermap.org/data/2.5/onecall. And we get that from reading the API documentation. In most cases, a base URL alone is not sufficient. So we take our attention to the arguments, or parameters, that the API can accept, information about which we also get by reading the documentation. When an API, any API, does take arguments, the base URL is followed by a question mark, indicating that what follows is a list of arguments. There can be any number of arguments separated by an ampersand, and each argument itself has a name, followed by the equal sign, and a value. Some arguments are required, while some are optional. Let's focus on the required ones for now. These are arguments without which the API will not produce any kind of usable result. The documentation tells us we will need a LAT argument, that's for the latitude, another LON argument for the longitude, and another argument for the app ID. The first two are obvious. The service needs to know the coordinates for which we are requesting weather information, expressed in terms of latitude and longitude. This last argument, however, the app ID, will be your unique API key. This is needed in order for the service to know who is requesting the weather data. The information is free indeed, but it does require registration. This is how the service can enforce limits for each user, such as a maximum number of API calls in a minute, an hour, or a month. So this means before we can do any API calls, we will need to create an account on openweathermap.org and get our own API key from them. So let's get to the browser and click on the Sign In button. From there, if you don't have an account already, click on Create an Account and go through the process of entering your data required for a new account. Once you have created an account and you are signed in, access the API keys page, where most likely you will already have a new API key automatically created for you. If not, you can generate one yourself. In fact, you can generate multiple ones if needed. I am showing you my own API key here in this video, but be warned, you will not have any luck using it, since I am planning on deleting it before posting this tutorial. You will need to make sure you create your own account and generate your own API key before going any further with building this app. Let's take a look on how our own API call will look now. Remember, it will start with a base URL, followed by a question mark indicating arguments follow, and a list of arguments separated by an ampersand. We already know the base URL, so we add a question mark, followed by the first argument, which will be the latitude of my favorite city in the whole world, Singapore. The latitude is 1.29, so we write the argument like this: LAT equals sign 1.29. No spaces, very important. Now we need another argument, so we add the separator, ampersand, followed by the second argument, written as LON equal 103.85. Feel free to Google the coordinates of your own favorite city if you want. I had to choose an example here, and I decided to choose Singapore. We need one last argument, which is the API key, which means we add another ampersand to separate between arguments, and we write the last argument as app_id equal and the actual API key we just generated. Copy-paste is our good friend here, but remember, no spaces. Finally, this is how the entire API call looks like. Let's test this in the browser right now and see what we get. If everything is written correctly, we should get back data in the JSON format right in the browser. This is not HTML, so the browser will not know how to decode it. Therefore, it should just display it as it is. If you don't see this, double check your API call and make sure you have no spaces, all ampersands are present in the right place, and all arguments have a name followed by the equal sign, followed by the value. Also, make sure you included a valid API key, one that is your own. If we do have proper JSON data displayed in the browser, as we should, we can now begin making preparations for UI previews before we even write any Swift UI code. When Swift UI was introduced not too long ago, it came with this feature called Previews, which is a great productivity tool, since it allows much faster development without the need to constantly running the app in the simulator to review changes made in the code. But we will need to have some preview data first, and the JSON data we just got in the browser is perfect for that. It doesn't have to be fresh data, it just needs to be data in the same format that we will have when running the app. So let's copy this entire data. It is basically just text from the computer's point of view, and paste it into a new text file that we can call singapore.json. I will assume you know how to do this, but make sure you create a simple text file and not a rich text file. A rich text file will contain information that we won't be able to decode later, such as font type and size, bold, italic properties, and so on. Save the file with the name singapore.json, or use the name of your own favorite city if desired. Once we have this file, we can go back to the browser and change the latitude and the longitude arguments in the API call for a completely different location. I will choose Paris this time, with a latitude of 48.85 and a longitude of 2.34. But you can choose whatever location you desire. It doesn't have to be Paris. Same as before, select the entire JSON data received in the browser and paste it into a new text file that you can call paris.json. Now do the same for a third location. I will choose a United States location this time. Let's say San Diego, California. It has a latitude of 32.71 and a longitude of negative 117.15. Save the data you receive for these coordinates into a new text file called sandiego.json. Now that we understand how to work with an API, we do have an API key from OpenWeatherMap, and we have 3 JSON files with proper data for previews, we are ready to start our own Xcode project. This tutorial is being built using Xcode 12.3 and Swift 5.1, and the deployment target will be iOS 14.3. If you decide to follow along with the code, make sure you are using Xcode 12.3 or newer. In Xcode, we start a new project with File, New Project from the Xcode menu, but Shift-Command-N also works as a keyboard shortcut. Choose a product name. I am choosing Tony's Weather for the product name, but You can choose whatever name you want. Then choose a team and an organization identifier. For the interface, we will use Swift UI, while the lifecycle will be Swift UI app, which is new to Xcode 12. Language, of course, will be Swift. We will not use core data for this project, and we will not deal with tests either, even though honestly, a good developer should write and run tests constantly while building a software project. I am assuming here that this is not your first time starting a new Xcode project, since this tutorial is targeted to individuals getting ready to interview for a junior iOS developer position. Now that we have our project started, the first thing we should do is to import those 3 JSON files we have previously created into the project. I saved my 3 JSON files on the desktop, so I can just drag them from there into the project. Make sure you select Copy Items if needed. We are going to use these 3 files to generate previews while writing code. Alright, that's about it for the first part of the tutorial. In the next video, we will start writing actual code and put our knowledge so far in practice. We will write our own data models, a function to decode JSON data into usable structured data, and we will build our first user interface subview. I hope to see you all next time.